This is our second day of Chapter 6. We're going to do a little bit of 6.2 and a little bit of 6.4. This is still part of Unit 5, Section 2. So just like pi is a letter that represents an irrational number, there's something called the natural base e, and it is also irrational, and it is about 2.71828182846. You're never going to have to memorize this. Your calculator has a button on it that says E, the same as it has a button on it that says pi. We learned about E for many reasons, a lot of which are going to come up in the next section we learn. But for today, we're going to learn about it in terms of compound interest being compounded continuously. So we learned about compounding interest annually and semi-annually, monthly, daily, but there's also something where it's done continuously. And for that, we use a different formula. That is going to be A equals P for the principal times E raised to the RT. So R is still our interest rate that we turn into a decimal. T is still the amount of time or years. And P, like before, was our principal balance or initial amount. So for our example here, when you finish kindergarten, your parents put $1,000 into an account that earns 2.5% annual interest compounded continuously. How much is in your account when you graduate high school? So we know a few things. We know our starting amount is 1,000. We know our rate was 2.5%, so if I move that over twice, it's 0.025. And time. If it was when we finished kindergarten, and we want to know what it is when we finish high school, we need to know how many years have passed between them. So once we finish kindergarten, we have to do grades 1, 2, 3, 4, and so on, all the way up to grade 12, which is when we end high school. So T would be 12. So we're going to take our formula, A equals PERT, P times E to the RT. And we're going to plug in 1,000 for P times E raised to the 0.025 times 12. So on our calculators, we're going to have to find the letter that actually says E. Let's look at where that might be. So if you have a Casio calculator, we have a button near the top right here that says E to the box. So that's what we would use to do E to any power. If you have the TI-30X2S, right here on the LN button, above that we see E to the X. So that's where it would be on that one. The TI-34 multi-view is probably the most difficult. So first we would hit second. Then we would hit the PRB button, because above that it says log. And when we do that, we're going to get a dialog box that's going to say log and it's going to say LN. And under log, it'll give you two options, but we're going to scroll over to LN and it's going to give you two more options. It's going to give you the letters LN and it's going to give you E like that. So we would have to select the second option to get to our E button there. For the TI-36X Pro, there's the E button is on the same button as pi. So notice there are three different things on this same button. So I would hit it twice to get to E. And then for the TI-84s, the graphing calculators, we have on here a button again that also says LN. So if you go all the way down on that column near the 4, and above that is E to the X. So we would first hit second, and then we would hit this button to get to the E to the X. So we're going to do that. We're going to find our E button, and we're going to raise it to the 0.025 times 12 power. And when we get our answer, then we will multiply by 1,000. So if we do that, our final answer is 1,349.86. All right, so you're going to go ahead and try the next one. A equals PERT, P-E-R-T. You're depositing $5,425. The account earns 1.6% interest, compounded continuously, and we're looking at 8 years. So try it pause, and check your answer. All right, so if we set this up, we're going to do e raised to the 0.016 times 8 power, then multiply that answer by 5425, and we get $6,165.80. So any function in the form y equals a number times e raised to something times x is called a natural base exponential function. So the a value is going to be greater than 0, and the r value is going to tell us if it's exponential growth or decay. So if the r value is positive, or what we're multiplying the x by is positive, it's exponential growth. And if what we're multiplying the x by is negative, it's exponential decay. So y equals e to the positive x is growth, like we see here, and y equals e to the negative x is decay, as we see here. So all we have to do is look at the number that is attached to the x to determine if it is growth or decay. So for a, this is 2/3 times x. So 2/3 is positive, so therefore this is growth. Right? That's all we had to look at. In part B, -4 is negative, so this is decay. So you go ahead, pause, try these, and then check your answers. All right, so for A, we have a negative x, so that's really a -1 is our r, which means that it's decay. And in B, we had 3.5 being multiplied by the x, which is positive, so that's growth. The last thing we'll talk about with this are the transformations. And we've been doing transformations of functions all year. So the same things are applying. We're shifting left and right, we're shifting up and down, we have reflections, and then we have horizontal and vertical stretches and shrinks. So if I'm adding or subtracting in the exponent, I'm adding and subtracting to the x. Same as before, except it just happens to be in the exponent, but it's happening to the x. That's how we're moving left and right. And again, it's opposites. So -3 would be 3 to the right, +2 would be 2 to the left. If I'm adding after it or subtracting after it, that's affecting the y. It's moving up and down. So +5 would be 5 units up, and -1 would be 1 unit down. The negative sign, if it happens on the x, it's reflecting in the y. So it's always kind of the opposite. On the x is going to reflect in the y. Not on the x is going to reflect on the x. Okay? And then the last thing would be our vertical and horizontal stretches and shrinks. So if we're multiplying in front of the e, that's vertical. So bigger than 1 is a stretch, so vertical stretch of 3. Less than 1 is a shrink, so vertical shrink of 1/4. If we're multiplying within the exponent, so it's 2 times x, this is again where I'm going to take the reciprocal. So the reciprocal of 2 is 1/2, so it's a horizontal shrink of 1/2. And the second one, 1/2 is the number, so take the reciprocal of that, it's 2. It's a horizontal stretch of 2. So knowing all that, we should be able to look at a function and describe the transformations that are occurring. And you will definitely have to do something like this on your final. So let's look at it one piece at a time. The negative out front is happening not to the x, so it happens to the x. So it's a reflection in the x-axis. Then I have something happening to the x up here. Oh, wait, I skipped something, that 1/2. So this 1/2 is being multiplied on the outside, so that's a vertical stretch or shrink. And because it's less than 1, it's a shrink. So we're going to have vertical shrink of 1/2, or by a factor of 1/2. Now we'll look at the exponent. So we're doing something to the x, so that means that's left and right, and it's the opposite. So -4 means we're going to go 4 units right. And stuff on the outside happens up and down. So +8 means it's going to go 8 units up. Looking at B, I don't have anything in front, but now I have two things with the x. I have a negative and I have a 7. So the negative, because it's happening to the x, is a reflection in the y-axis. And then the 7 is happening to the x, so that's going to be horizontal. So I'm going to start by taking the reciprocal. So the reciprocal of 7 is 1/7. So that's a horizontal shrink of 1/7. And then the -2 is happening after it, so that means it's going to go 2 units down. All right, so for the last one here, you're going to describe the transformations from g of x equals e of x, e to the x, given by f of x equals 3 times e to the negative x plus 4. So try it, pause it, check your answer. All right, so for this last problem, we had a vertical stretch of 3 with that 3 there. The negative was in the exponent, so that's a reflection in the y-axis, and then plus 4 meant 4 units up. So that is section 6.2 with a little bit of 6.4 sprinkled in.